All right. So these are reminiscent of a couple of days ago where you were, actually yesterday, where you were dealing with the converse theorem. So what we're doing on this one is looking at the actual theorem and then trying to prove it in a variety of ways. So on the previous one, we started off with it as isosceles, and then we chose that it was midpoint. Here we're going to start off with isosceles and do this little angle bisector thing. So we'll go ahead and look and see how that goes. So we'll start with our, I'm just going to do this part here and not rewrite the whole thing like I did on that one. I know I'm being lazy, but oh, I've got to get these done. Okay, so this is our given. And we also have that BD bisects angle ABC. So if this is an angle bisector, it cuts the angle in half. It does not cut the side in half. It does not cut this at a perpendicular. So again, if the triangle was drawn slightly differently, that would be my angle bisector. It would not be hitting at 90 degrees, and it would not be cutting that into two equal parts. So be very careful that you only use what is given, and you don't just assume a bunch of stuff that isn't true. So angle 1 is equal to angle 2, and we have that because of the definition of bisect. We have this marking here, and we've got our BD. So we just carry on. Triangles are congruent. SASA is in between the two S's. And what am I trying to prove? I'm trying to prove that D is the midpoint and also that angle A is equal to angle C. So again, directly from there, angle A is equal to angle C because of congruent triangles that give me congruent parts, which means that we've essentially proven the isosceles triangle theorem again. And we also know that these two sides are equal. Why do I care? Because I'm trying to prove that D is the midpoint. So if I can use those two sides, then because they are congruent triangles, then I can say that D is the midpoint because I know what a midpoint is. So I'm stating the definition of midpoint. Okay, so two completely different ways of proving much the same types of things. Let's go ahead and do 3 as well. You've actually done this before. You've done this a few days ago, so you're just proving that if this is a parallelogram here, so actually I'm not going to do the video again. You can just go ahead and watch in this packet earlier.